So we're going to go into the dynamic series connectors. We're going to talk about target markets, applications, product offerings for dynamic series, explain the product design and features. So the target markets for these are like IC industrial control, human machine interface. Dynamic series connectors do play a major role when it comes to the machine part of the human machine interface. Then we have data communication, motion and drives, production equipment. So normally where all the other connectors are also used as a target market, even the dynamic series target markets are connectors are used in the same target markets. There's no difference between other connectors getting used and the dynamic series. If you see, there are some industries which are not common with other connectors, like the numeric controllers, variable frequency drives, switching power supplies. These are kind of like used in the switching power supplies can be used in heavy machinery or heavy industries. The numeric controllers can also be used. For example, if you say where is a numeric controller used, then we have the factory automation computers, something like a supercomputer, and which helps in the automation of the process in the factory. In those computers also the dynamic series products are used. So if you see robotic arm, these are the applications: printing press, CNC lathe machines, shock test equipment, control cabinets and generators. Now, why do you think a dynamic series connector is used in all these kind of applications? What is the benefit, or what is that feature of the dynamic series that helps in use for this wide range of applications? So what do you think is common in all these equipments that we see that dynamic series connector is used? High density, high signal and high power applications. This is why the dynamic series connector family is used in the control system applications and is suitable for a wide range of applications. Why? Because it requires high density, signal and power applications, and the dynamic series is just the best product to be used in all these kind of applications. If you talk about these robotics arms or the robotic systems, they utilize the series for all of the wire to board and wire to wire applications. So we do have two types of applications, right? One is wire to board, one is wire to wire applications. So all this dynamic series, the robotic system, they use the dynamic series of products for all this wire to board and wire to wire application. Let's talk about some of more examples. Like you have the motion controller, that's a Yaskawa motion controller. It's a control unit. For electric vehicle, you have the battery module management control, and then in the inverter, frequency inverter control unit for offshore wind power. These are the examples of some of the applications examples. Let's take an introduction to the dynamic series, because these are an alternative to terminal blocks. So what are the four features that we have of the dynamic series? We have the high performance contact. What do we mean by a high performance contact? The large high performance contact area prevents chance of disconnection over time, and it is made up of high conductivity material, and we also do have the gold plated versions available. And now I'm taking the introduction for the dynamic series, and I'm giving the 4 points for the dynamic series. So the first point is it's a high performance contact. So we have the major points of high performance contact is that it is made up of high conductivity material. Gold plated versions are also available, and since gold is the highest conductor of electricity, that is why gold plated versions are available, so that the contact remains stable and it prevents the chance of disconnection over time. Coming to the second point, we have a robust housing structure. Alright, for the robust housing structure, it is vibration resistant, which is designed to withstand the most demanding and inhospitable environments. Now, in the previous slide, we saw the target markets and the applications. They are very rugged, they are very, if you see the robotic arms would be constantly in vibration. And if we do not use the dynamic series, dynamic series are the best apt for these kind of applications, because they would be in a very hostile environment or a harsh environment. They would be always in vibration, and because of that robust housing structure, it becomes a very useful product for these kind of applications. Retention legs and contacts provide additional strength, acting as a strain relief and ensuring reliability, and clear visible circuit numbers. These are some of the points for robust housing structure. After that, we have a secure and fast installation. What do you think when you see this term secure and fast installation? It is very easy to install. The click sound makes sure that the connectors are properly latched together and they do not disengage by accident. And there's another point to it. The housings, they are keyed. If you see a lot of our catalogs, in some of the catalogs we'll have keying positions, right? So what does that keying position do is the keying position prevents mismating. Since in these dynamic series these keys are present, or housings are present with these keys, it will prevent mismating. So you just have to click it and plug it inside. You do not have to actually see what is the arrangement of the pins and all that stuff. Because of these keys, it will prevent them for mismating. So the installation process is faster. So the same thing, if you see in the secure and fast installation, the housings and everything is color coded so that it prevents human errors as well. And then, as you all said, the locking sound that makes it clear that the connection is secured. Now comes flexibility. Why do you think flexibility plays an important part in the dynamic series? So since it is used in all these robotic arms, it is used in gen sets, it is used in all the harsh environments. If flexibility is not an option, do you think that the connection would be stable? It will just disengage. So you need to have flexibility, because these are used in this during this some of the motors and all that stuff. Flexibility is very much necessary for this dynamic series connectors, because it will be constantly, some of the applications or some of the machines will be constantly in motion, and if you have a rugged connector, there might be instances, or there would be situations wherein it will just get disconnect. Okay, it will not have that that flexibility of twisting around or the flexibility of bending, so it might get disconnected or it might disengage, which will again hamper the application. We need to again reinstall the connectors. That's why dynamic series are helpful in these kind of situations wherein flexibility comes into account. So as we talked about dynamic series, we have wire to board, wire to panel, and wire to wire connectors. Now let's go into the key features of housing. Twisting prevention. Okay, there's a safety rib maintaining the stability. We have the audible lock mechanism. So if you see the diagram, the second that looks like a side lance, we can call it as a side key or the side lance. Then we have the shock and the vibrant resistance for harsh environments. The contact retention lance. So these are some of the you can say the parts of this housing. So what does the contact retention lance do? It makes sure that the contacts is staying in the housing. Okay, so retention means what? Prevention. If you take the literal meaning of retention, what does that mean? It means prevents or keeps. You can say it in a very localized language, it keeps that in place. So what happens is when the contacts come in, it produces a latch sound, producing an audible click when the contact is inserted into the housing. So you have two latch sounds. One is in the contact retention lance and another one is audible lock mechanism. So this is what it makes sure that the connector is plugged in perfectly. Again, the keying mechanism, as I said, it prevents incorrect insertion. Then we have the printed circuit here and the time protection. Housing is fully covering the shoulder tine. So if you see, these are the shoulders of pins which the housing is protecting it. Then we have the PCB retention legs. When is PCB retention legs used, or why it is helpful? It reduces the strain to the wires. So when the PCB circuit is holding it, okay, and when you're applying pressure, it will it will act as a strain relief to the wires without harming the wires. That is why the PCB retention legs are beneficiary. After housing, we are going to talk about the key features of contacts. We were talking about all these multiple contact points, where the wire comes in the insulation barrel, then where the wire is crimped, which one the insulation support act as a strain relief to the wires. So it's the same thing over here. It's again, we are talking about contacts, but in the dynamic series. Okay, so we have the multiple contact points. There are 3: anti-overstress structure, and then we have the support beam or the auxiliary spring. So if you see here the image to the right, we have the receptacle contact, then we have, as we said, 3 contact points, and then we have the main beam, the support beam. What does the support beam do? The support beam acts as a supporting lever to reduce the stress of the wire. And then the anti-overstress structure, it reduces the strain and it makes sure that the contact is in place. But if you are trying to insert the contact into the auxiliary spring, what it does is, since it is a spring, what it will do is it will bend itself, and then when the wire is inserted, it will just collapse again. That is the function of that auxiliary spring or the support beam. Now we do have the wire sizes, the AWG from 30 to 28. I think it's small, medium, large, XXL, 28 to 22. Again, these are the wire range marks that goes into this contacts or this, in which the dynamic series can be used. Alright, so now let's go into the subcategories of the dynamic series. So if you see here, the dynamic series family covers applications up to 65 ampere, signal up to 15 amperes. So we have the series. Please remember the series and the features. So D1000, we're going to talk each series in detail, but just take an overview of this one. D2000 series, 3000 series, 4000, 5000, 7000. So the 7000 takes up to power up to 65 amps, whereas the D1000 takes up to 15 amps. Let's talk about the dynamic signal application connectors. We are talking about some of the features of this D1000, D2000, D3000, but we are going to go into more detail also. So the D1000 is divided into 4 subcategories, or there are 4 parts in that family. We have the D1100S, that is a single row type. So you imagine, whenever I say single row, I used to feel it very easy to imagine a comb. Okay, a comb is a single row. Then dual row, again add another row onto that comb. Then we have 3 row types as well. And spring clamp, when the wire comes in, the spring comes into the action and then it holds the wire tight. Next is the D2000 series. In the D2000 series, we again have the 2100S, 1, 2, 3, 4, the dual row type, the dual row combined type. We'll go and see what does a dual row combined type looks like, and the drawer type, which is 50 positions. Now D3000, if you see here, both signal and power. The D3100S is the first row type. 3100M is the modular 2 row type. We are again going to go into all this, so don't worry about how does it look. 3100D, 2 row types. And then the D3100S is the SMT type. SMT is surface mount type. Then 3200S is high voltage 1 row type. 3200M is high voltage 2 row types. Then if you see here, the 3200T is a high pressure 3 row type. Then one we have, which is known as the skyscraper type. Skyscraper is nothing but a tower. So then the D3700 is the servo motors connector, and D3900 to 3950 is the spring clamp. Now let's talk about D1000. If you see here, the dynamic series 1000 features. Okay, now first please take a note of the wire range. Everybody please take a note of the wire range. The wire range is 30 AWG to 18 AWG. Now if you see here, What is the centerline spacing? 2.0 mm. That's another point. 2.0 mm for the 1100. Now, what is the current carrying capacity? 5 amp max and 125 VAC VDC. That's the voltage. Current carrying capacity is 5 amps. Now, if you see crimp termination, yeah, the wires are crimp termination for 1100, 1200, but only in 1900 we have the spring clamp termination. W2W is wire to wire, WTB is wire to board. So these are the features of the D1100. Now for the 1200, if you see here, the 2.5 mm is nothing but the centerline spacing. And for the D1500, it is the 3.5 mm. Okay. Now D1900, we have the 3.5 mm centerline spacing. So the D1500, what is the common feature between D1500 and 1900? Centerline spacing. Okay. But if you see, the voltage is less, current carrying capacity or the amp is also less. 1900 has 4 amp, 1200 has 5 amps. There are another options on which is given for the D1000. We have got two plating options. One is gold and one is tin. Can you tell me why do you have gold, or why, let's say we have gold and tin option, plating option? It is cost effective. So both gold and tin are good conductors. First and foremost, gold and tin are very good conductors. Now why do we give different plating options? Depends on the cost. For economy one, you know, the customer can go with the tin plated.
Tin is, it can withstand a lot of heat. So in that case, it's mostly used in power applications, but whereas gold is really good for signal. So signal is, gold contacts are perfect for signal applications.
Now let's go into the D series 2000 features. So for the D200 2100S, we have as the 2.5 centerline spacing. Now see the current capacity, current carrying capacity 5 amp maximum, 250 VAC and VDC. Crimp termination, wire to wire and wire to board. That is for the features for 2100. Next, for the 2100M, the centerline spacing remains the same and the current carrying capacity decreases to 2.6 amp. 2100S, it's the 5 amp. 2100M, it's the 2.6 amp. Okay, but if you see, the voltage is the same, 250 each for all the D2000 series, 2100, 2100S/D, 2100M and 2600D. The voltage is 250. Only there is a difference in the current carrying capacity, which is 5 amp in case of 2100S and D, 2.6 amp in case of 2100M, and 3.2 amp in case of 2600D. The wire sizes that the Dynamic Series 2000 can use is 18 AWG.
So the 2000 only uses 18 to AWG.
If you see the 2006, this is the 2600D, this is the dual row, then we have the single row, and then again the 2100D is the dual row type. Now if you see, let's see the 2100M. We were talking about the drawer type. This is how it looks like. It all looks the same, but in different angles, the terminology changes. Next, it's the D series 3000, which is very commonly asked. So we have the 3100, 3200, 3950 as of now in this page. So if you see, the current carrying capacity has increased, okay, from the other series. It's 15 amp for the 3100 and 3200 and 14.5 amp for the 3950. Now, what is the other change that you see apart from the amp? What was low in the Dynamic Series 1000 2000? The current carrying capacity was low. What else do you think apart from the voltage and the current? what else do you think is a major change from the dynamic series 1000 and 2000? The center line, there's a difference in the center line. The current carrying capacity also increases and the voltage also increases. So if you see the D3200, the center line is 5.08 mm, 15 ampere, and see the voltage 600. Okay, and 7.5 center line spacing, yeah, 14.5, 300. So that's way above what was there in the D1000 and the 2000 series, right? That is why this D3000 series is so popular. There are 3 plating types. One is tin, the other 2 are golds, but then it depends on the thickness as well, the plating thickness. So normal environment, a tin plating can be used. Where there are large number of insertions, gold plating of the thickness is 0.38 mm or m, and where the environment is much more harsh, again a thick gold plating is used. So there are 3 types of plating used here. Normal tin, 2 gold platings with different thickness. Now one more thing, it also has the audible latching and keying, because dynamic series as a whole has the audible latching and the keying, so that keying prevents mismating, and audible latching helps us to know that the connection is secure. The termination, we have the wire to wire, wire to board, and again wire to wire, wire to board for the 3200 and wire to wire as well. Again, we are going to talk about the rest of the dynamic series 3000. For the D3200, the center line spacing is 5.08 mm. The current carrying capacity is 15 amp, and see the voltage 600. D400F skyscraper. Okay, it gives multiple input and output from one header. That is why it is called a skyscraper, because of the vertical height. Now for the D500D, it is a sensor. It is used commonly in sensor applications. So D3500D is used in sensor applications. Now for the 3700, we have the servo motor. Servo motor is used in automobile industries, so these connectors are made specifically for that servo motor application. Now for the 3900 and the 3950, if you see the center line is 2.5 center line spacing, it is a spring clamp. Most of the times what it was? Crimp, right? Now it is spring clamp. It is wire to wire. The current carrying capacity is 14.5 ampere and the maximum is 300. Let's go and look into the D4000. So for the D4000, we have 2 families. We have the D4200S and the D4200M. So high current 1-row type and standard modular 2-row type. These are the dynamic series 4000. Now what is its importance? What is its what is the advantage of the D4000 series? The space. It offers an optimal size, and due to the pitch of the 4000 series is 6.3 mm. Standard pitch is 6.35 mm, and the wire size is 16 to 12 AWG. 16 to 12 AWG. Imagine what is the current capacity. It is 24 ampere. That is the dynamic series 4000. We have 2 4200S and 4200M. For the dynamic series 5000, you can say that this is the main power series offering most options, okay, apart from the D3000 series. The standard pitch of dynamic series 5000 is 10.16 mm. I'm going to write that down. Standard pitch is 10.16 mm, and the current carrying capacity, imagine again, as the number goes higher, the current carrying capacity goes higher, 45 amperes. The voltage is 630 voltage, and the wire size is 20 to 8. That's the range of the wire size of D5000, 20 to 8 AWG. Okay, now going to the 7000 series, it's for higher power applications. The standard pitch is 16 mm. So imagine what would be the current capacity size. 7000, pitch is 16 mm. The current capacity is 65 amps. Again, 630 voltage, and the wire size is 16 to 8 AWG. That's for the 7000. From the 4000 series, the current carrying capacity is getting higher. Then the voltage is either in the high 500s and 600s. Now going into the D4000 series, if you see, we spoke about the 6.35 mm center line spacing, 24 ampere, 600 volts. The termination type used is crimp termination, and we have wire to wire and wire to board. The D4200S, for the receptacle ones, we do have the 4 contacts, but if you see the 4200, we have how many? We have 6 contacts there. So 4200S has how many contacts? 4. Aaron said it correctly. And 4200M has 3 of 2. So how much is this? 3 into 2? 6, correct. Okay, now we do have the 3 plating types here. The 3 plating types is like 1 tin and 2 gold plating with different thickness. Okay, we do not have any other plating types. So I'll write, it's the exact same type that we wrote. Features of 4000. Alright, for the dynamic series 5000 features, 45 amp max, 630 voltage, crimp termination, wire to wire and wire to board, and it is 10.16 center line spacing. If you see here, the keying position helps prevent mismatching. If I look at this, the D5200M receptacle housing has how many? 4 contacts. So what is the difference between the free hanging time and the plug? See, receptacle is different, free hanging time and the plug. Receptacle is what? The housing, okay, or the cap. Plug is nothing but the male part number, right? But underneath plug we have free hanging and we have plugs and PCBs and all that. What is the difference between that? We have wire to wire and wire to board. When it is wire to wire, that is when we use the free hanging part. When it is wire to wire, free hanging. Wire to board, the other ones, the mount, the panel mount. So that is about the D5000 features. So if you see here, wire to wire means free hanging type. Okay, and this is like panel mount, board mounting horizontal. Okay, now let's talk about 7000. Center line spacing is of 16 mm, 65 amp, 630 VAC VDC, crimp termination, W to W and W to B, wire to wire and wire to board. It again has the 3 plating structures. It's the same tin and gold with 2 thicknesses. The same exact what I wrote for the D5000, I guess. That's the same plating structures that we have for the D7000 series as well. Okay, so these are the features of dynamic series 7000. So this is like glossary of when to use the 0.38 and the 0.76. Below 3 voltage, below 1 amp, bad environment, take standard pressure, high pressure. Okay, so basically you need to know what kind of environment is that application in. Okay, if it is too rough and all, go for the gold plated thickness of 0.76. How much is the pressure that's going to get? With that, we come to an end of the dynamic series product introduction.